Good day, everyone. My name is Allan Asma from Tondo, Manila, Philippines. My research is all about forecasting earthquake using machine learning. Earthquakes have always been unpredictable, and this is still the case today. Still in jeopardy are several lives and properties. The Philippines has had 10 of the most devastating earthquakes in recorded history. The highest earthquake first is the Moro Gulf earthquake in 1976, 8.1 magnitude. The second is the Luzon earthquake in 1990, 7.8. Number three is the now earthquake, 1955, having a 7.5 magnitude. Number four is Casiguran earthquake in 1968, having a 7.3 magnitude. Number five is Bohol earthquake in 2013, 7.2 magnitude. Number six is Mindoro earthquake in 1994, 7.1 magnitude. Number seven, Panay earthquake in 1990, 7.1 magnitude. Number eight is Rigay Gulf earthquake, 1973, 7 magnitude. And number nine is Negros Oriental earthquake in 2012, 6.9 magnitude. And number 10, which is the last, Balimbang earthquake in 2002, 6.8 magnitude, which encouraged the researcher to examine different models to achieve the best model utilizing machine learning to forecast earthquake. The researchers employed ARIMA as the baseline model for DNN, RNN, LSTM, CNN, and CNN plus LSTM, then compared neural networks to determine which model had the lowest error. Research elaborations. The process of data analysis of ARIMA and machine learning. ARIMA is a statistical approach. Many data manipulations had to be done before modeling, like the following: transform the data, make sure it is stationary, check the residual and other assumptions. Machine learning approach. Less manipulations, only having to feed the data into the network. But there are four steps. First is the data processing. Second is the building the model. Number three is training the model. And the last is making the predictions. ARIMA model and extensions of the ARMA model used in statistics and economic tricks is particularly effective for analyzing time series data. This model are used to forecast future points in a series or to better understand the data patterns. DNN, a deep neural network, is an artificial network with deep layer between the input and output layers. RNN is the kind of artificial neural networks that Google Voice Search and Apple Siri employ. Because RNN have internal memories, they can remember past inputs, which is important for tasks like text generations, transcriptions, and machine translations. A normal neural network's inputs and outputs are independent of one another, whereas an RNN output is reliant on the sequence's prior elements. Recurrent networks exchange parameters between network layers as well. Each node in a feedwork network has a different weight in RNN. The weights and base are independently updated during the gradient descents, where each layer of the network shares the same weights. LSTM is more complex RNN designed to prevent gradient problems from deteriorating and erupting. Although the structures is different, repeating modules are present in both LSTM and RNN. LSTM has four interacting communicative layers as opposed to a single layer with one another. Machine translation, speech synthesis, speech recognitions, and handwriting recognitions are just a few of the sequential tasks that can benefit from LSTM's four-layered structure. Next is the last is CNN is a deep learning system that can distinguish between object is an input image by assigning them different attributes in weights, learnable weights, and biases. A convenet requires far less pre-processing than conventional classifications techniques. Even if filters are hand-engineered in basic approaches, convenets can learn this filter in attributes with enough practice. Result and findings. They assess which model is suited to predict earthquakes. The researchers utilize the hybrid time series in machine learning statistical model. We have a summary table for accuracy metrics using the mean absolute error. The first is the first model is the ARIMA, having a 0.3317 mean absolute error. The next is linear, having a 0.3611. Next is DNN, having a 0.2401. Next is LSTM, having a 0.2320. Next is the CNN, having a 0.2710. And the last is CNN plus LSTM, having a 0.2340 main absolute error. Under the accuracy metrics, the LSTM is the lowest main absolute error. Next is the summary table for predicted magnitude from August 2022 until July 2024. The highest magnitude indicated under ARIMA model is 5.9 month of February 2022 onward. For CNN model is 6.4 month of May 2024. For DNN model is 5.9 month of July 2024. For linear model is 8.3 month of April 2024. For LSTM model is 5.8 month of October 2022 to January 2023. And for LSTM plus CNN is 5.9 magnitude month of October until November 2022. From the summary table for accuracy metric, LSTM model with a 0.2320 main absolute error was shown to be the most or the best model to utilize in forecasting earthquakes in the Philippines using the ARIMA time series baseline forecasting approach of machine learning models. The chosen model can assist in mitigating potential damage and casualties. Conclusions. The basis of comparisons in the model use the mean average error to uniform the basis for forecasted error and to make it easier to understand for the readers. The best software applications to be used in Python is Python for ARIMA, linear, DNN, LSTM, CNN, and CNN plus LSTM. Thank you for watching.